Guys, welcome back. Hope you had a great weekend. We're going to go ahead and jump into Monday's lesson. The next topic we're going to cover is arithmetic sequences and series. If you didn't go ahead and print these notes out from Google Classroom already, go ahead and do that now. You can just pause the video, come back when you're ready. Or you can copy this down on some blank paper as we go. Okay, so let's go ahead and jump right in. As always, it's super important that you're putting your name at the top of your notes and the date. This is actually Sunday today, so I'm doing this on today's the 5th. And you want to go ahead and put the Unit H, Lesson 2, Lesson 3 right here into the topic section, and then the class will be your period number. It's really going to help me to distinguish the notes when I'm grading these if you guys go ahead and fill this out completely at the top, so please make sure you're doing it, okay? Alright, so the first thing we're going to cover is what is an arithmetic sequence. Well, an arithmetic sequence is a sequence of numbers, and it's when there's a common difference between the two terms, and it stays the same every time. So for example, if I gave you the sequence 1, 2, 3, 4, 5, I'm adding 1 every time, so the difference between each term is the same as we go. So let's go ahead and fill that in. This is a sequence where there is a common difference Okay, it's a sequence where there is a common difference between each term and it is constant. Okay. The next term we're going to define is what is a common difference. The common difference is that numerical difference between each terms and each term in the sequence, and we're going to give that a variable. We're going to call that D for difference. So let's go ahead and jot this down. The numerical difference between each term, and we're calling this the variable D. Okay, so in these problems I'm going to refer to the common difference as just D. Okay, so let's go ahead and do the first example here. So determine whether the sequence is arithmetic. And if it is arithmetic, then go ahead and identify the common difference and say what the next 3 terms are. So let's look at number 1. The way that I like to do this is just kind of jot this down between each term and find out what the difference is. So 5 and 8, the difference is 3. 8 and 11, the difference is 3. 11 and 14, the difference is 3. 14 and 17, the difference is 3. And so we can say conclusively, yes, this sequence is arithmetic, so this is going to be a yes. And it also said to find the next 3 terms, so if you're going to find the next 3 terms, you just keep adding 3. So the next 3 terms would be 20, 23, and 26. Okay. Let's look at the next one. We have 23 and then 16, so the difference between those is 7, and then it's actually minus 7. And then 16 and 9, the difference there is again minus 7. And the difference between 9 and 2, minus 7. 2 and negative 5, minus 7. So we can say once again, yes, this is arithmetic. And the next 3 terms are going to be given by subtracting 7 3 more times. So negative 5 minus 7 is going to give me a negative 12. And then you take away another 7, negative 19. And then another 7 gives you negative 26. Okay. I think you get the gist here. I'm going to go ahead and leave the next 4 problems as examples for you to work out as classwork. So I'm going to circle these 3, 4, 5, and 6. Go ahead and try those out. If you want, you can go ahead and just pause the video here and then work them out while we're still on this section. Okay. Let's move on to the next part of the notes. This is going to be about the arithmetic sequence formula. So in the sequences they showed us already, what they gave us were the first couple of terms that are in those sequences. We figured out what the difference was, and then we can keep going from there. There's actually a formula that you can use to find any term in a sequence based upon the rule. So let's go ahead and define what the rule is. The rule we're going to follow here is that the nth term in any arithmetic sequence can be found using this formula. The rule is a sub n, which stands for any term, so any term in the sequence, is equal to the common difference, which is d, and then you're going to multiply that common difference by the number term you're finding minus 1, okay? And then at the end of that, we're just going to add whatever the first term of the sequence is. So there are a few things you need to know in order to do one of these rules. You need to know which number term you're finding, because you need to know what n is. You need to know what the common difference is in the sequence, and you also need to know what the first term of the sequence is. Okay, so we can fill in the two blanks that are here. A sub 1 is going to be the first term, and d is going to be the common difference. Okay, so let's do some examples. In number 7, it looks like they're saying write a rule for each sequence and then find the indicated term. So here's our sequence. Let's go ahead and figure out what the common difference is so we can already define what d is. So the difference between -5 and -1, to get from -5 to -1, you're adding 4. To get from -1 to 3, you're adding 4. To get from 3 to 7, you're adding 4. So it's safe to say that our value for d here is going to be 4, okay? We also know what the first term is because they gave us the sequence already. So a sub 1 is -5. And they said to find a sub 24, which is the 24th term in the sequence. So n is 24. Basically, at this point, you're going to take these three variables, which you just defined right here, and you're going to plug them into the formula that was given in the notes up here. Okay? So let's go ahead and create a rule out of this. What this is saying is that a sub 24, that's the one we're looking for here, the 24th term. The a sub 24 is going to be equal to the common difference times 24 minus 1, and to that we're going to add the first term of the sequence, which is a sub 1, which is -5. Okay, and they also said to go ahead and find what that term is. So we're going to do a sub 24. We're just going to solve this and figure out what the 24th term of the sequence is going to be. We can plug that right into our calculator, and we get 87. Okay, so let's go ahead and do another example. We're going to do number 8. In number 8, they gave us a sequence, and they want us to find the 15th term using the rule. So let's figure out what the common difference is. To go from 20 to 11, you have to subtract 9. From 11 to 2, you have to subtract 9. From 2 to -7, you're subtracting 9. Subtracting 9. So the common difference here is that you are subtracting 9. Okay, so let's go ahead and define that. So d is -9. Okay. They told us the first term because they gave us the sequence already. The first term is going to be 20. And then we also know what n is because they told us we're solving for the 15th term, or a sub 15. So n is 15. So we can go ahead and apply this in order to fill in the formula. So a sub 15, the 15th term of the sequence, can be found by multiplying the common difference, which is d, times n minus 1, so 15 minus 1. And then to that, you're going to add the first term. The first term is 20. So that's the rule. And then we can actually solve this and figure out what a sub 15 is. If we use our calculator for this, we would just do -9, 15 minus 1. Yes, of course, you could put 14 in there. And you find out that the 15th term is -106. Something you'll want to check, I didn't do that on 7 or 8, but I'm going to explain it now. So something you want to double check here is that you want to make sure the answer you got goes along with what the sequence is. So for example, you're starting out in number 8 at positive 20, and you're subtracting, and so your number is getting progressively more negative. So if I found a positive value for the 15th term, that wouldn't make sense logically, so maybe I have a calculation error somewhere, and that's just something you're going to want to double check as you go through these, okay? I'm going to leave 9 and 10 for you guys, so let's circle 9 and 10. 9 and 10 are classwork. Okay, and then we're going to go ahead and we're going to flip the page here, okay? So on page 2 of our notes, let me roll this up so you can see, we have some different types of examples. The difference being that if you take a look at the problems we were just doing and the problems they want us to do now, in these problems we had the first couple of terms of the sequence, okay? And in these problems we don't have the sequence, we only have, in number 11, we only have the first term of the sequence and the third term, okay? So that's all we were given, all right? Let's go ahead and take a look at this type of problem. The directions say that if the given terms are part of an arithmetic sequence, so they're telling you it is an arithmetic sequence, there's going to be a common difference. Then you're going to write the rule for that sequence and find the 12th term, okay? So let's do a little bit of reverse engineering here. If the first term is 3, okay, so a sub 1 is 3, and the third term is negative 7, that means that n is 3, okay, and d is a question mark, okay? You don't know what the common difference is by just being given these terms, so you have to kind of go a little backwards in the formula and figure out what the common difference is. Then you can go ahead and find the 12th term, okay? So let's refresh ourselves. Any term in the sequence, I'm just jotting the formula down on the side here. So any term of the sequence can be found by multiplying d times m minus 1 plus the first term. So with all the things I just defined here, do I have everything I need in order to find the common difference? Will that be the only unknown left if I plug all these things in? And the answer is yes, it will be. So let's do that. So that means the third term, which is negative 7, is going to be equal to the common difference, which is the thing we don't know, okay? And then to that, we're going to be multiplying n minus 1. Well, this is the third term. So the third term minus 1 would be 3 minus 1. Okay? And then to that, we're going to be adding the first term of the sequence, which is 3. All right. So let's do some algebra and solve this. Let's take away 3 from both sides. So minus 10 is d times 2. And then we can divide both sides by 2. And we can find out that the common difference is minus 5. Okay? And we can actually do a quick check on our math here before we proceed at all. If the common difference is minus 5, go back to your first term. If you have 3 and you take away 5, that's negative 2. Okay, that would be the second term in the sequence, would be negative 2. And then you need to do minus 5 one more time to get to the third term. Negative 2 minus 5 is negative 7. So we are confident now that d being negative 5 is correct. Okay, so that was only half the problem. The other half of this problem is going to be figuring out the 12th term. So let's go ahead and we can cross out these question marks over here because now we know that d is negative 5. And let's go ahead and do the 12th term. So a sub 12 is going to be equal to the common difference, which we now know is negative 5. In parentheses, we're going to do 12 minus 1, or 11. And then we're going to add the first term to our result. Okay, so that would be the rule. And then we're going to go ahead and we're going to solve this so we can find out what the 12th term is. If you punch this into your calculator, you're going to get negative 5, 12 minus 1, plus 3, and you get negative 52. Okay, so this is a two-parter here. So you need to figure out what the rule is that you're going to follow, and then what the actual result is of finding the 12th term. Okay, I'm going to leave 12 for you as a classwork. So you can check that example out, okay? The last section of the notes here, there's just one more thing, which is an arithmetic series, okay? Series and sequences are different. Remember that a series is actually a sum of the numbers that are in a sequence, okay? So you're going to be adding up some terms here. Let's go ahead and fill that in. So it says, recall that a series is the sum of a sequence. And when you're finding the sum of an arithmetic series, what you need to do is use a very particular formula, and I'm going to give that to you right now. The formula that you can follow, actually let's use green, I'm trying to keep a pattern here. So the sum up to any term in the sequence, so a problem is going to tell you find the sum up to the 10th term or the 8th term or the 5th term or something, so n is going to tell you what term you go to, okay? The sum up to any term in that arithmetic sequence is going to be whatever number term it is times the first term in the sequence plus the term that you're looking for in the sequence, the value of the term, I mean, and then you divide that by 2. Okay, so there's your formula. N is going to be the number of terms, and a sub 1 is the first term, and then a sub n is going to be the number term that you're looking for. Or the number term that you go up to when you're doing the summation. Okay, so let's look at 13 and 14. It says find the indicated sum for each series. Okay, actually I think what I'm going to do is I'm going to do 13 and 15 because 15 is in sigma notation, and so like 16 will go with 15 and 14 would go with 13, so those will be the ones that you try, okay? So let's look at 13. We have a sequence listed here of 2 and 4 and 6 and 8 and dot 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 dot. The common difference here, it looks like it's 2 every time that you do one. The common difference will be 2. But you're not even really solving for that. You don't really need to do anything with d, the common difference, at this point, because if you go back to your formula, okay, there is no common difference implied here at all. There's no lowercase d variable in order for you to plug something in. So let's just try applying what we know to the formula. It says to find the sum up to the 10th term. So if we do that with our formula, changing colors. If we do that with our formula, that's going to be s sub 10, or summation up to the 10th term. That's equal to n is 10, and then the first term is 2, and then the last term, or the term that we're going up to, which is the 10th term, we don't know what that is yet, okay? And that's all going to be divided by 2. So we need to figure out what is a sub 10, okay? So a 10. So A10 equals question mark. So what is the 10th term? Well, you know the common difference, so you can pretty much figure out what the 10th term is, okay? If we were to make a chart like we've done in the past, we can definitely do a chart here, if that helps. So let's make a chart. So first term, second term, 3, 4, 5, 6, 7, 8, 9, 10. This will be the number of terms, and this will be the value of those terms. We already know the first term is 2, second term is 4, 6, 8. Keep adding 2 every time, and you'll get up to the 10th term. So 10, 12, 14, 16, 18, 20. Okay? So this right here is 20. A sub 10 is 20. Okay, so now that you know that, you can solve this formula, okay? So let's do this math. 2 plus 20 is 22, divided by 2 is 11. 11 times 10 is 110. So the summation is 110. When you add up all the terms, 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20, you're going to get 110. And if you don't believe me, add it up on your calculator. All right. Let's go ahead and do 15. 15 is in sigma notation. That means that we are starting at the first term and stopping at the 12th term. That's the sum that we're finding, is the first 12 terms of the sequence. And this is the rule to find any term that's in the sequence will be 6x minus 4. Okay, x being the number term that you're looking at. So there's a couple things that we need to find out. So the first thing is we have to know that s sub 12 is what we're solving for, okay? Because we're getting that sum from the first term all the way up to the 12th. The n being 12 is where we're stopping, okay? That's the number term we're stopping on. We need to find out what is a1. So that's going to be 6 times 1 minus 4. And that's going to give us 6 minus 4, which is 2. And then we need to find the last term, which is a sub 12. That's going to be found by this rule, 6 times 12 minus 4, okay? That's 72 minus 4, which is 68. Okay, so we have now found the first term and the term we're stopping at, and we know that n is 12, so we have everything we need to go back to this original formula here and plug that stuff in to find that summation, okay? So let's go ahead and do that. S sub 12 is going to be 12, which is n, times this big quantity, that's the first term, plus the last term divided by 2. And I know the inside comes out to 35, but I don't know what that is times 12 off the top of my head. It's 420. So this is going to be 12 times 35, which is 420. Okay, that is the summation that you're looking for. That is the summation up to the 12th term. Okay, so I'm going to leave 14 and 16 for you to practice with. Numbers 14 and 16 are classwork. And just like we've done in all of the previous lesson videos, I'm going to be giving you 2 grades, assigning you 2 grades for this assignment for this lesson today. The first is I'm going to have you upload your notes. I'm going to be giving you points for filling in your notes all the way. And then the second thing is going to be completing the classwork problems that are circled in the notes. That's your practice to go along with this. So I need to have those completed also in order for you to earn full credit for this assignment, okay? All right, so until I see you guys again, enjoy and hope everything's going well in all your other classes, and we'll be back in class on Wednesday. All right, bye-bye.